Welcome to my channel. In this video we will start with the tool Simscape. Simscape, a multi-domain language, is an extension of Simulink for modeling electronic, mechanical, hydraulic and thermal systems. Blocks in the Simscape libraries represent components such as resistors, transistors, motors, etc. Simscape includes several libraries, such as the one for electrical, thermal, mechanical or hydraulic. If we take the example of a direct current electric motor, by double-clicking on its block, we have default values, such as its electrical parameters, resistance and choke, and the armature or mechanical, resisting torques, etc., that we can modify according to use. The Simscape library is displayed directly using the following statement from the MATLAB command window. Basic multi-domain library, foundation library, contains the following libraries following: electrical, basic elements of electricity, hydraulic components, magnetic elements, pneumatic elements, thermal components, mechanical parts. Physical signals. This library contains the physical signals to switch from one domain to another through Simulink. Let's consider the RC circuit, as follows. The study of the circuit, we will use the following libraries from the library electrical elements, electrical sources and electrical sensors. We apply a V-in step of 5 volts. This is done through the step block of the library Simulink sources. The signal, type S, is first converted into a PS for physical signal. To obtain a voltage in volts that is applied to the circuit, we have to go through a controlled voltage source. We first start by building the circuit using physical components from Simscape. By double-clicking on each of the components, we specify a variable that defines it, which is given a numerical value in a callback function such as initial function of the Simulink model initialization step. We apply 2 steps to the RC circuit, a high step of height 5 volt at time t equals 4 second, then a low step, from height 2 volt to t equals 12 second. The sequence of steps is generated by the signal builder block. The Simulink signal is first transformed into a Simscape physical signal, PS, by the Simulink to physical system, PS, converter. And that we transform then in voltage by the controlled voltage source from the electrical sources library. This following model, we use 2 voltmeters, voltage sensor, for the measurement of the input voltage, following the controlled voltage source, and another for measuring the voltage across the capacity. For each Simscape window, we must associate one and only one solver block fx equals 0. This block allows us to specify the parameters of the solver used for the simulation of the model Simulink with physical components from Simscape. Note that if you want to put Simscape's physical signals into the multiplexer, we have to transform them into Simulink signals via the PS to S converter, in Utilities library. The File, Model Properties, Callbacks option, we can program the commands to be performed by Simulink at the beginning and end of the simulation. Callback InitFcn function, initialization function, in which the numerical values of the components are specified. This function is called as the beginning of the simulation. Callback StopFcn function, end of simulation, allows, at the end of the simulation, to read the binary file apply_circuit_rc.mat and to draw the different curves. Programming this StopFcn callback function allows the binary file to be read and the various curves to be plotted, the input voltage, the one at the terminals of the capacitor. The first component of the vector of a binary file is always the simulation time. If we want to measure the current flowing through the RC circuit, we use an ammeter or current sensor from the same library as the voltmeter or voltage sensor. We put this ammeter in series with the capacitance. By double-clicking on the PS to S converter, we can choose the unit of the quantity to be measured, here A for ampere, or put 1 to avoid any error in the choice of unit. Thanks to the plot YY function, we plot, simultaneously, the voltage at the terminals of the capacitance C and the current that crosses it in the same graph with two different coordinate axes. This command is programmed in the StopFcn Callback function after reading the binary file. The current jumps from 5 milliamperes, then changes exponentially to 0 when the capacitor becomes charged to the value of the input step, in steady state. PS to V subsystem allows you to switch from the physical voltage signal to the Simulink signal of the same tension. The PS to I subsystem performs the same function for the current IT.
We have reached the end of the video. Thank you very much for your attention. Do you have any questions? All the best until the next video.